So, primer on binary trees, we're going to talk about what a tree is, what it consists of, and why we would want to use this. So, understand that we're coming from in C++, we're coming from a language of linked lists, right? We've developed linked lists, we've used them in projects. We even explored vectors and lists and stacks and queues in the standard template library. Now, what we want to talk about is probably the single best collection in C++, the idea of a tree. Trees are used in a number of different applications. So I'm a Mac guy, as you guys know. In the early days of the Mac, the layout of the hard drive was kept in what was called a B tree. A B tree is a special type of tree. We may or may not talk about that specifically. But anyway, it was a tree structure. So what is a tree structure? Well, a tree structure, and more specifically an upside-down tree structure, starts at something called the root. There is a single root. You can call it the trunk if you want to, but there's a single point of entry. It's called the root. The root is the top of the tree, and it's called a tree in that it looks like an upside-down tree, really. So there's a single root part, and it extends out to the branches and leaves. Each one of these is a leaf. So this here specifically is a leaf of the tree. All right. One of the special parts of a tree is that it'll have two pointers on it. So there will be a value, and it will have two separate pointers, a pointer going left and a pointer going right, representing the two base branches of the tree. The tree can only go in two directions. There are special trees that'll do multiple, but we're not going to talk about those. We're only going to talk about trees that'll branch in two directions. So from your root, you'll either branch left or right, and based on the value of what's here. So much like a linked list and how we determined what if we had a value in the linked list, in other words, we would follow the list on. Here we actually have to make a comparison as to whether we are greater than or less than the value. So if we are less than, we go down the left branch of the tree. If we're greater than, we go down the right. If we do not find our value, in other words, if we go down the right and we don't find the value, we encounter a null pointer, then that is an entry point for a new leaf on the tree. When leaves get added, their left and right pointers are null unless they're added in line. So in other words, if this is a number scheme here, and we have 1, 2, 3, 4, and 5, right? If we were to add 6, and actually, I'm sorry, that would be 1, 2, 3, 5, and 4. Because remember, when we're left, we're less than, right? So if this is 5, our left branch has to be less than 5. So if we were to add 6, we would come in here and we would encounter a 3, and we would say, oh, we're greater than that. And we would encounter a 5, and we would say we're greater than that. So this right pointer here would get the 6, not this pointer down here. All right. Note that we are, it's a left-right thing. If we're less than the value at this node, we go left on the node. If we're greater than the value on that node, we go in the right hand of the node. That's how a tree works.